Good afternoon, everyone. Good to see a few hands understood what SBOMs and understood the importance of the COA. They will appear in the slides later on. So this afternoon, I'm going to talk about progress on a project that is funded from NGI. So we've had this morning a very good session in terms of sharing some knowledge. So I want to share what I've been doing, the journey on the last 12 months on this funded project. Explain a little bit more about me. So Sebastian said, yeah, I've got a lot of experience delivering mission critical systems. Think about mission critical systems are solutions that never really finish because you're continually evolving them. Things about like our critical infrastructures. So I now run APH10 as a consultant, basically evangelizing SBOMs. I've been on a mission going around UK and Europe selling what SBOMs are. And I'm a co-founder of an organization called SBOM Europe. So I encourage you to look at SBOM Europe because we're trying to help people get up to speed with SBOMs because you need them for regulation. I contribute to open source software. You're going to see some of that in this talk. I also mentor what I'll call the next generation because I want to share my experience in terms of developing software to the next generation because I want secure software to become the default. So I do that through things like the Google Summer of Code, where I'm a mentor. I do it through an organization called Coder Dojo, which is part of the Raspberry Pi Foundation, which is looking at making software fun for students. I think we all need that. I am based in Manchester. That is a B. Manchester, we work a B. We work hard. And Manchester is not London. Please be aware of that. We also have a few football teams you might have heard of. And I spend time running around muddy fields most weekends. That's a great way to get rid of technology. So what's the motivation for this project? If you think about it, we have a lot of old software out there, legacy software, that's been there, it's just been working, it's been running in our infrastructures, our control systems, and we've probably lost track of where it's come from. It's probably built in the days when security wasn't a word. We didn't think about it. It's built maybe 10, 15 years ago. And we've probably lost track of the source code because GitHub wasn't there. It might have been in Subversion or think about another old version control system. And quite likely, it's written in a language called C or C++, which doesn't have a language ecosystem the way that we have with Python or Rust or Go. And we have particular interest in security for the embedded world because we rely on the embedded world to deliver our services to citizens across the world. So I need to work out how we can get more insights about the software. And as we all know, the CRA is coming. And one of the big things that the CRA requires is to understand the cyber risk of your digital products. And the software components in your digital products are potentially that risk. If you don't know what those components are, how can you manage that risk? And I particularly like this one statement. I know there's 78 statements in the requirements, but this one statement really resonated with me because it implies so much. What's a known exploitable vulnerability? How can you assert that your product doesn't have any? And there's lots of definition. What's a vulnerability? What's exploitable? What do you mean by known? But let's just unpick that. But that's a really important point that every business needs to understand. So the outcomes of the project was I wanted to generate SBOMs for binaries. I wanted to look at a binary application and see, could I generate an SBOM? And we'll explain what an SBOM is later on. But what we also wanted to do is, could we then support the traceability of that binary back to the source? So you've then got that connectivity between the source code and the executable. And we wanted to do that by providing a searchable resource. So how are we going to do this? So first of all, we take a binary. In the scope, we selected that we were going to look at an ELF binary, which is typically on your Linux type environments. We were going to extract certain features, make that storable, and then put a search engine around that store. But in parallel, the features you extract from the binary could then also be used to generate an SBOM. And that was where the original idea came from, but then we broadened it. So the key things we're looking for are the symbols in a binary and the library information that the binary is using. So I created a first tool called BIDS Analyzer. The reason it's called BIDS, Binary Identification of Dependencies with Search. I will thank my colleague Philippe Obradam for coming up with that great acronym. You need an acronym for a project, don't you? So we looked at ELF binaries because there's a lot of good tooling already out there that allows you to extract those features. So I wanted to build on the community to do that. So a tool called PyElf Tools, Python, provided all the heavy lifting in the interrogation of the binary, of the ELF format. I also used typecode, which is part of the scan code ecosystem, which allowed us to confirm what type of binary we were looking at. So if somebody tried to use this with a Windows executable, I would be able to dismiss it. I then created a JSON file. And the reason I wanted a JSON file is because JSON is very easy to then manipulate. But then that could have some key features, and some of the information I started storing in there was with a view to creating an SBOM. So the sort of information I'm extracting is like the architecture, the operating system, where on the file system the file came from, when was it built or delivered onto your system. That's quite an important date. And then various checksums. So straight away, you've got a record of what that binary is. But let's try and get more information. Let's try and find the dynamic libraries that executable needs and where that binary, where those libraries reside. So we resolve the library name to the actual location on the disk. And where possible, I try and find the version. That's quite hard. We'll see a little bit later on some of the challenges that I sort of exposed and then I had to go back about. And then I get all the symbols. And so what I immediately noticed was you have a library, something like libc has hundreds of functions, but most of those functions you're not using. So we've been able to capture what functions you are using straight away may be a useful feature for you to when you start looking at exploitable vulnerabilities. Because if the vulnerability is in a function that you're not using, that's a very quick win. And then you can then map that to the actual library. So straight away you can see libraries have many functions. I can then identify which functions are actually being used. What I wanted to initially do was trying to find out whether I was directly using them or whether they were implicitly being used just as part of the execution. I wanted to do something called a call graph, that became too much of a challenge. So if anybody would like to tell me how to do that easily, please contact me, because it ain't easy from what I looked at. And then I wrote a utility to say, okay, I want to generate and analyze many executables in one go. So let's create a utility that does that efficiently. So there's a utility that does that for the whole directory. Let's moving on to the search. So Philip introduced me to an engine called Tantivy, which is a Rust-based search engine inspired by the Lucene engine that comes from Apache. Tantivy is written in Rust, and it's also done so it's a traditional inverted indexing approach. Think a little about Google, so you use some prioritization. Fortunately for me, because I don't know Rust, but I do know Python, there was a Python bindings, so that helped the integration to be quite straightforward in terms of using the power of the engine into a Python application. So therefore, you can then go and index a whole directory of the JSON files that I've just created, and then we can then start command line doing search. So at the moment, all my tools are command line. I like command line. I'm old. Command line is what I came up with, was brought up with. But straight away, you could just give it a search term, which functions are using struct copy, and it takes straight away, it identifies the most likely candidates. Think Google, old-fashioned Google before AI. So it gives you a score. And if you wanted a more detailed and more verbose report, you actually can get exactly that return, the whole of that JSON file that's being used as the part of the index. So you can get a lot more information out from a verbose report. So I got this working 5-6 months. This is sort of typical NGI project. It's sort of in my spare time. I then submitted my project to for the security audit. Radical Security are supporting NGI projects have a contract with Radical Security to provide that security audit for projects. And I found it quite insightful for someone to look at my code that I think works, well, it does work, but actually get somebody to give me an independent viewpoint. And I learned an awful lot about things little oversights that you sort of take for granted. So, yeah, I got code coverage. I'd improved my code coverage to get, the 90+%, which is where I was my target. But one of the things I was doing was I was doing a lot of sub-process handling. So I was calling out to another sub-process. From a security perspective, that's potentially an attack vector. So they recommended that I used a sandbox. And I'd never used a sandbox before in my applications. So they introduced me to a number. I chose something called FireJail, open source, of course. And I integrated that. Inevitably, that breaks things. It's broken the version handling that I was trying to do. So I need to go back and fix that. But I have a more secure project, which is great. I also have better file handling. I'm lazy when it comes to file handling. So they use an SCA tool, they use semgrep, another open source tool. Other ones are available, but they just use semgrep. And again, that was useful. So let's move on to the generation side, which is where initially I was aiming for. So I wanted to take the process binary and create the SBOM. I already have a library that generates SBOMs. I've built a suite of tools around that, gradually getting some contributions, but clearly people are using them because of the feedback I get. But let's first concentrate on some of the challenges we have with SBOMs. We have two standards, SPDX and Cyclone DX. And while they are essentially the same in terms of what they're trying to deliver, they have different strengths and different weaknesses, and they've come from different points. We haven't got time to go into all those subtleties. Catch me afterwards and we can sort some of the details. But generally, SPDX and Cyclone DX are our tooling, and you're finding people are generally going on one side or the other these days because to get that integration. So the SBOM is the machine-readable format to be shared internally and externally as part of your risk strategy. Comes back to the CRA. But ultimately, it consists of 3 bits of data. Some metadata, when it was created, who created it, the list of the components, and the relationships those components have. And I'm really interested in those components because that's what I want to know. I want to identify the components. That's what the aim was for this project. But what you also need to know is vulnerabilities are often reported against libraries, but really it's a vulnerability of a function within that library that you really want to identify. So there's actually a challenge in terms of how you can actually give that level of fine-grained granularity to identify the functions that are being used rather than just the library. Because if you say I'm using libc, that could be any more of over several hundred functions. Actually, you'd much rather know I'm only using these particular functions. So what I had to do was that I chose Cyclone DX. The reason Cyclone DX is chosen, it's extensible, allows me to add additional attributes to the SBOM, which then allows me to actually expose things like the function names. So on the left-hand side is standard SBOM showing a dependency. Reference 1 is the name of a component, and that depends on 2 other libraries. On the right-hand side, you can see a little bit more details about the library, where the library resides on the system, when it was released, and the functions that we're using. Very extracted straight out of that JSON file. However, there are some challenges. If you have strict binaries, and if you're doing security, that's probably one of the things you're probably going to do to mitigate potential exploits, then you basically will get less data. I also have challenges with call gas, I've explained. It's not trying to be a security tool on its own right. So if you have malicious software hidden in your ELF binary, I'm not going to detect that. So this is a call really to help. Join that community and help me make bids better. And really one of the things I really want to do is I've got to complete the scope, which is to add a UI to all the command line utilities, integration with a couple of open source projects, but ultimately really need to build up a database of all these symbols so we can then start sharing them and we can start using them to make our software more secure. I've trailed it with a few friends, and they said, well, what about static libraries? Because you embed them and you lose the dynamic, you lose the resolution because they're hidden just as symbols. So maybe that's something in the future to look at how we could build that up. Look at the language that's maybe, is it C, is it C++, etc. And some other work I've been doing, this all would also apply for something like Windows as well. So it might be very useful to look at the Windows file format in the future. So there you are, that's my contact details. Please follow me on various bits of LinkedIn, etc. Contribute to my GitHub and make my software better. Thank you for your time.